and we have Tim here.
Phoenix.
Hi, right, I can see you, I can hear you. And right, feel free to share your presentation from your side.
Okay, let me just do that.
Right.
Are you seeing this already?
Yes, yes.
Great. Should be on full screen now, right?
Yes, now it's full screen. So yeah, you may start.
Great. Thank you very much for the introduction, Phoenix. I was just listening to some of the comments and questions. Was very interesting. I hope I can shed some light on some of the topics, but specifically, Tony, the purity things that you just mentioned and the deblending part is very interesting. We're looking into this as well. So curious, and hopefully I can shed some light on this. So before jumping into the presentation, my name is Tim Heisterkamp. I'm heading the technology and environmental policy at Linde. Today, I just give you a very, very quick introduction, and maybe some of you have seen me before, because I remember, Phoenix, the last presentation that I did was, I think, in 2020 on the overarching topic of green hydrogen. I think today, what I want to do is walk you through some of the applications that we see a lot of movement, a lot of development in. One of them being heavy duty. Maritime is something where we see things happen slowly, but in the heavy duty area, I think there's a lot of movement there. And then kind of walk you through what we think and also the government's view that I get from at least a lot of governments here in the EU on the specific questions of storage and distribution and what's to come there. Before I do that, allow me to give you a very, very brief introduction to who I represent here. So Linde is one of the biggest industrial gases company. We've merged in 2018 with Praxair, a US-based company. There's a lot of numbers here. I think what's key regarding hydrogen, that already today, hydrogen is a $2 billion annual business for us globally. But I mean, that's no news to all of you. 99, 97, 98, the way it depends on how you look at that, is currently produced from steam methane reforming and other processes that are based on fossil fuels. So we're kind of looking into the transition as well as everybody else does with new technologies. But the topic itself has been with us as one of the core things that we do for more than 100 years. So, and just to top off the quick introduction, the industrial gases companies, and that's not only true for us, but specifically for Linde, we are one of the companies that are basically active along the entire hydrogen value chain. So you have the production part, then you have storage, liquefaction, the processing of the gas, the purification, some of the topics that the speakers just discussed and touched upon, and unlike some other companies, we not only produce, store, and process, and then transport to our customers via different means of transportation, but we're also engaged in the end customer segment when it comes to mobility, because we do develop hydrogen refueling stations, the attached technologies to that, liquefaction, and these kind of things. So basically, we cover the value chain. What we are now looking into specifically with regard to green hydrogen is something much more upstream, specifically the renewable energy part, because that's going to be key for making this a success. And I think today, one of the questions that we have to look into is storage and distribution. Besides all the other, the production part and the offtake part, there's a lot of movement in there, a lot of regulatory topics that have to shift or that are currently being discussed. And these two pillars, storage and distribution, are key pillars to make hydrogen economy, whatever customer or sector you're looking at. These two pillars are key to make this a success. So to make it a fail or to make it a success, it depends on how we cope with that going forward. Now, kind of switching into some of the topics, and Phoenix asked me to integrate something that some of you might have seen in the press. When it comes to heavy duty specifically, we're looking into trucks and trains and these kind of applications within mobility. But lately we've seen some movement, small movement, but very positive movement on the maritime front as well, which is why I quickly want to introduce you to a project that we are conducting in Norway with a ferry company, with some partners, Bellad amongst these partners for the hydrogen and fuel cell part. That's very interesting to see this happening, because, and I will get into these details later, but within the maritime sector, we're seeing a lot of developments around decarbonization, around LNG and other, let's say, technical possibilities to decarbonize these fuels and operations, specifically for the ferry and the kind of ferry that we're talking about here in Norway, which is going, and you can see this on the right. It's basically doing some kind of island hopping here in a triangle route. It's very interesting because we do have a constant payload. We do have a plannable route. We don't go too far out. So all of these criteria can make these maritime projects with hydrogen a quick success. Although I would say the larger ships, when it comes to cruise ships, to large cargo ships, I think they are much further away, also in terms of costs. However, it's interesting to see some smaller companies moving into this sphere. And I mean, if you look at the ferry, it's basically a smaller type ferry carrying 300 passengers, cars and trucks that we're talking about here. And interestingly, and we had to go through some design challenges. Of course, as I said before, we had to partner up with a lot of companies here. We were specifically looking into the question, how can we bring liquid hydrogen onto a ferry, also in terms of venting, excess hydrogen, all the safety regulations that you have to have in place on a ship. It's even, I would say, more of a challenge if you put liquid hydrogen on such a ship. The good thing is with these ferries, and that's specifically so for liquid hydrogen, you don't have a lot of boil off that is being basically the liquid hydrogen that is evaporating, because you're on a constant route going in that triangle. So you have a very plannable route, you have a good time for refueling, and that makes these fast moving projects in maritime very interesting. And that's what this ship looks in real. So it's basically being built, has to be finally commissioned, and we're looking forward to taking this into operation and see if we can get more hydrogen ferries into operation soon. So, I mean, coming from the maritime now, and as I said, that's one example, but the main trend that we see, and I think that's one of the key things that I want to go a bit into detail, is the heavy duty application area. And it is interesting because the industrial gases company and other companies have basically been approaching the clean hydrogen or the hydrogen topic, the fuel cell topic, very much from a mobility standpoint, from a mobility perspective. But the thing that we did in the past, specifically so in European geographies, if you take Germany for an example, we looked at this from an angle with a focus on individual mobility. So we're talking cars. Maybe we're talking forklifts with hydrogen, but that's not the typical mobility that we were looking at. We were specifically looking at cars. And with that came the typical chicken-egg dilemma. I will go into that on the next slide. But the overall thing that we saw, I would say, in the past decade is that with the cars, specifically in Europe, we didn't live up to the expectations that we had in terms of market penetration. So what we did is that we kind of overcame this chicken and egg dilemma, but still we don't have the penetration of cars in the market, which will then lead to profitability problems or problems within your mobility business cases, because the stations are invested, they're producing cost, and you don't have the throughput because you just don't have enough cars on the market. Which is why now I think most of the companies have turned their view more towards heavy duty applications. The trains is a special case, I would say, but it's very interesting, specifically for those train lines that cannot be electrified. Hydrogen is a very good topic to decarbonize and switch from diesel to other fuels such as hydrogen. And I know there are developments in France, in the UK. So we're really eager to look into this. But there are also other reasons, because not only do companies such as Linde switch their views, but we do see a lot of activities from the OEMs. Specifically so from Asian OEMs, but also from German OEMs that have been considerably slower on the car part. They are now much more active in looking into heavy duty and trucking. Why is that so? Because the regulation is changing, is becoming more pressing, basically, to reduce the powertrain and CO2 emissions, specifically so in the EU. But also because on the mid to long run, and if you look at these cases, we have a very high payload with these trucks, long distances and very short refueling times. This is very hard to solve this with battery electric vehicles. And that's not me or an industrial gases company talking, but that's the feedback that we actually get from our customers. companies like Hyundai, Daimler, Volvo, CNH Industrial, Iveco, all these companies, Nikola, you've heard of all of them. They're specifically looking into this segment. So I think there's a lot of movement here. Of course, the question is, do we have enough capacity to come up with green hydrogen? That's a topic that technology and gas companies have to solve, which is why we are heavily investing into a 1 gigawatt plant, which we do with ITM Power in the UK to really ramp up the production facilities for electrolysis. But also on the OEM side, we see a tenfold increase of production capacity for cars and for trucks. So there's a lot of movement there and a lot of projects popping up. However, I think where there's light, there's also a bit of shadow still and some challenges to overcome, which I try to summarize here. And coming from basically from the individual mobility story, the problem that we see, the same problem that we see within heavy duty that is remaining, or the challenge that we see, is the TCO perspective. If you talk to logistics companies, if you talk to companies, why should they invest in a technology for a truck or bus or maybe even a train if the TCOs are still considerably higher than other, I would say, technical solutions? And basically there's two reasons why. Either you don't have any other options, or you have very, very strong regulatory framework that kind of pushes you into these technologies. But still, we have to bring down the overall TCO for these applications to get them much more into mainstream usage and to scale it up. How can we do this? I think there's different ways and different responsibilities. And it's always the same story. I think on the OEM side, there has to be a scaling up in vehicles, but specifically looking at the infrastructure side and the gas side, we have to bring down the investment costs for the stations. We have to bring down the cost for the green molecules. Again, this is only happening by volume and by scaling up the production. Then something that we did is to modularize and standardize the stations. I would say 10 years ago, a decade ago, station production that we did and the architecture was very individual. Now we're talking about modules that you can basically fit and put together, and we started a serial production for these stations, which is always a good step ahead. The second point, and I alluded to this in the slide before, is the infrastructure question. Who's going to invest? And the same, which was true for the cars, is true here. You don't want stranded investments, but also you don't want to bring out the trucks that cannot be refueled because of a lack of infrastructure. And there's a clear solution from the experience that we have specifically in Germany. How we can overcome this is by partnering and by going into joint ventures or public-private partnerships. We've done a thing here in Germany. We have brought OEMs, industrial gas companies, and utilities together in what we call H2 mobility. For the car part, we will jointly invest and build up and operate 400 stations, public stations, until 2023. We're well on the way for that. And then I think we have to focus on clusters. And that's a very good thing with heavy duty. You don't have a few cars coming, I don't know, once or twice a day. You have very plannable demand of hydrogen because in most cases, you have a back-to-base route or back-to-base logistics supply, leaving in the morning, coming back in the evening. So you can really plan the demand that you have, the size, and kind of tailor this to what the customer needs so that the business case is becoming quickly profitable and you don't have stranded investments. Of course, some part of this can and will still be in the bridging transition phase, public funding, and there's a lot of legislation that can push this development. Last but not least, the point of standards and codes and standards, I would say, but more standards on the refueling. For this, and you've seen the same within the cars, we were talking different pressure levels, 350 bars, 700 bars. We've been testing out liquid, and the same discussion is currently going on with the heavy duty OEMs. And for that also, we have to do a cross-industry approach to really get one standard that we can use from Korea to US and to Germany. We've done so successfully in the car part. So there's one protocol, but we need to do the same thing basically for trucking. So basically, to summarize, I think there's a lot of development, a lot of potential in the heavy duty part, and specifically looking at the high payloads, the distances that we have to overcome here. Hydrogen in the trucking area makes a lot of sense. Again, and you see this today, looking at ports, looking at kind of clusters where you already have a lot of production of hydrogen, sometimes excess hydrogen or green hydrogen, where you also have a lot of logistics companies already running the operations. These would be the clusters or the first locations to go to and conduct these heavy duty projects, I would say. And I think that's very interesting to have a closer look at what I just said. Maybe start on the left side here. This is a picture that kind of displays, I would say, the mobility part of the value chain for clean hydrogen. So ideally, you will have green power supply. You may already have a pipeline in the soil that you can use to distribute. You have some storage capacity, tanks, whatever you have, electrolysis to take the grid or off-grid power and produce green molecules. And then the question is, how do you distribute this via pipeline, via compressed trailer that you see here? And it's interesting, you see right here the amounts that we can deliver. So the liquid hydrogen, I'm going to go into the details in a bit. We have 3.5 tons in a trailer, and we have 0.9 tons if we compress it and bring it to these stations. And a lot of these heavy duty stations, they are delivered by liquid hydrogen, because we need the higher energy density in liquid, and we don't want to go there, I don't know, in 2-3 times a day with these trailers. So that's why a lot of these applications will see liquid supply. But the most interesting part, also from a business perspective, is the right side, because what you see here is the demand in kilogram per day that we see in the different applications. And if you just have a look, the cars, I mean, that's 1 car per day, right? You can already imagine to get, if you have an investment for a hydrogen refueling station, you have to have a lot of cars running constantly, generating throughput, because if you don't, you will risk to have an investment being made that has service and maintenance costs and is not going to become profitable quickly. And already with buses, you see the higher load per refueling. And that's why trucks are very interesting, specifically so also the trains. For ships, I would say this is very optimistic, and these are would be big carriers that we don't see yet. We have to be a bit conservative on when we see these numbers. So I would say with the big ships, I would be a bit more cautious. But the point here is that you see there's a lot of potential in the offtake and the volumes that we talk about in the heavy duty applications. So that already leads me to the last part, where I would like to a bit bridge from, I would say, the applications and the question where the hydrogen is going to, how do we get it there? And I mean, that's part of the discussion that we have today, and the title of the conference, it's storage and distribution. This is why I want to share this slide with you to just give you an overview of what we're talking about, what kind of scale are we talking about, and what kind of technologies already today do we have in place, and what are we looking at in the future. So what you see on the top line here is the scale, and we're talking, these numbers are showing tons per day. So tons per day of hydrogen being supplied. And then right here in the middle part, you would see different technologies, basically the supply modes, and in the bottom part, you would see the end use segments. So I think traditionally, with very small amounts going into labs and testing and this kind of processes, we're talking about the classic gas cylinders that all of you know that we also use for oxygen. The interesting part when we look into creating hydrogen economy starts around here, where we're talking about bulk GH2, that's gaseous hydrogen, and liquid hydrogen, bulk LH2. So the industry feedstock, which is chemical industry, steel making, glass industry, food industry, we can easily trail in or truck in gaseous, compressed, or liquid hydrogen. The same is true for the stations, for the hydrogen fueling stations. But once this kind of kicks off, and we're talking about the range of 10 to 100 tons per day, we are already talking about on-site production. That would in this case mean that we have a production asset on site. And you will see this, for example, in refineries. You might even see this in some cases with refueling stations and heavy duty applications, where we have an electrolysis plant, a processing, purification application, and some kind of storage at the site where we do refuel. And the next step, and I think that's the transition to go, and also to connect to the discussion that I heard some pieces of from before, what we ultimately want to have in place to make hydrogen economy successful is this bar right here, which would be a pure H2 pipeline. We do operate roughly 1,000 kilometers of hydrogen pipeline globally. I will get into this in a bit. So that's technically absolutely feasible, but I think the bridging part is interesting, which would then be using a natural gas pipeline by either using assets that are empty and not used anymore for natural gas, or by blending. And as we've heard before, I think from Tony, the blending part is specifically difficult because, and we have the same view, the business cases are not there for creating and producing such a valuable molecule via electrolysis and then blending it into a lower energy natural gas. So ultimately, and that will also bridge the gap to power generation and buffering, we will have to have some kind of pipeline system in place in the future to really efficiently distribute the gas. And not only to do this efficiently, but to do this at lower operating costs than today by trucking, and to do it in a more ecological way. Because if you just feed something into a pipeline that is already an asset in the soil, you don't have to, again, create emissions by trading around these molecules with trucks. Some of this shipping part is already happening today when it comes to an energy vector. We've heard discussions about ammonia, methanol. But it's also interesting to see Japanese companies like Kawasaki developing the first liquid hydrogen carriers. And I think that's the future also for liquid hydrogen, but I think we will need some more time to go into this in terms of research and development and bringing down the cost for these chips. So as I said today, I think this column of the overall value chain, and I'm not going to go into the details of the production processing applications. That's something that we've talked about here, specifically the refueling part. I think this part here really is key and has to be in place in terms of regulation, in terms of costs to make this system a success and to pave the way for an overall hydrogen economy. Because you have to have these storage capacities and you have to have a pipeline network in the ground. Another thing that we are specifically looking into to also make the deliveries more efficient is the liquefaction part. So I want to quickly jump into this. How did we come across that? I think everybody knows that we started within the NASA space program, and currently today we are supplying liquid hydrogen to SpaceX as well. The fact is that within liquid, the energy density, of course, is much higher. We have some conventional industries where we also supply liquid hydrogen, but it's specifically interesting for heavy duty applications that have a lot of hydrogen throughput. We can deliver to a station. The station doesn't have to have so much energy going into the cooling because the gas itself is cryogenic. It will only be evaporated by becoming warm and can then directly be pumped into the car. So there's certain advantages to the liquid hydrogen part in terms of efficiency and energy density on this side as well. Just a quick outlook on where we stand in terms of liquefaction capacity, because that could become a potential bottleneck as well. Just some brief numbers here. You see a lot of liquefaction capacity due to the space programs that we see in the US today. The red bubbles that I'm showing here is the planned capacity that we want to invest or others want to invest. So I think this is something that you always have to keep in mind when we're talking about liquefaction. When we're talking about liquefaction also in parts of Australia to bring, I don't know, liquid hydrogen to Japan or other countries in terms of import and exporting hydrogen. The capacity for liquefaction could become a critical point. More interestingly, I think, and I copied this out of a EU publication, is the overall idea of having this, and the EU calls this a hydrogen backbone. I think it's very interesting. And you can basically transfer this to any other region of the world. But it's interestingly being pushed by strongly being pushed by the governments here in Europe to create some kind of network to really basically copy the natural gas grid that we see in Europe, but set this up for a hydrogen economy. And I think that's the right way to go. It's going to take some more time. The approach from our point of view could be twofold: to first start using or refitting natural gas grids. There's a lot of capacity becoming available because the fields in the Netherlands, for example, are running out of supply. The second step has then to be to develop and do new investments into a pure hydrogen grid. And you will see this covered by most of the hydrogen strategies in Europe. Some points, I think, just briefly, but I heard them out of the discussion that have to be solved. The financing, I mean, who's going to invest? That's chicken egg dilemma. Maybe the state has to step in partially for this as well. But also the technical specs, these discussions are still to be done. And in connection to the purities and the technical specs, we do see a lot of liabilities that have to be taken into account. To give you one example, in the natural gas grid, we're talking about percentage purities or impurities when it comes to a pure hydrogen pipeline network that has, for example, chemistry customers or off-takers. We're talking about a ppm, a parts per million purities. So it's a different world in terms of purities. With safety and materials, it's not that complicated. And I don't say this is not to be solved, but it's something that we have to take into consideration. And last but not least, just a quick outlook on what we think is also key for storage beyond trucks, beyond tanks, and beyond liquefaction is caverns. And I know there's always a geographical limitation, but in some geographies we also see a regulatory limitation. But we have been running such a cavern, a huge cavern in the US Gulf Coast, more than 10 years, very successfully. Of course, there has to be made a very high initial investment for the mining and exploration part. But once this is being set up and you have the cluster allocated around, you maybe even have pipelines connecting your customers with that cavern. You have pipelines connecting the production facilities with that cavern. It's, from our point of view, the most elegant and efficient way to basically cope with supply and demand changes, and also to do the buffering and storage part, because this cavern can specifically take out the volatility that we see within some of the renewable energy production, transfer the energy into the electricity into hydrogen, either use that hydrogen as a feedstock for the industry, or if you want to do this, re-electrify and put back into the grid. So there's endless opportunities there. And that would be my last slide on this, just to give you a picture on the dimensions that we are talking about here. So it's huge numbers. And what we've done here, you see the Gulf Coast of Mexico. There's a lot of petrochemical industry allocated around here. We have them all connected basically via pipelines. The red square that you see here is the cavern. So what we do is we basically feed in from these different locations into the cavern, and we take out from the cavern into the pipeline. And that's very efficient. It saves us a lot of truck trailing and storage on site. And I think that's the ultimate way to go if we're looking at some kind of, I would say, overarching hydrogen economy with all the different elements in that. A cavern or cavern storage, wherever possible, I think is a great thing to do. That was my last slide, and now I'm happy to hear your questions.
Thank you, Tim, for your presentation. And we have your poll question here. So
yes,
we can